In this video, I'm going to go through the process of coding myunique. So in this function, our input is a vector or a 1D array of a bunch of different numbers. Our outputs are going to be, we're going to have two outputs, U and H, where U is going to be an array with all of the unique numbers in A, and H is going to be an array with all of the number, with the number of occurrences of each number in U. So in this case, we're going to have U and H. Use capital or lowercase. As long as you're consistent, doesn't matter. So U is going to be all the unique numbers. So I see I have a 2, and there are 1, 2, 3, 4 occurrences of 2. Next, I see I have a 3, and there are 1, 2, 3 occurrences of 3. So next, I have an 8, and there is just one occurrence of 8. Then I have a 6. There are 2 occurrences of 6. And then lastly, I have 5. There's just one occurrence of 5. So that's what I want my code to do. There are so many different ways that we can program this function. The only rule we have is that we can't use the unique function because we're essentially writing our own unique function. So when I was doing that, let's go through, I should have kind of talked it out as I was doing that, but I found that 2 was a unique number. And then I kind of erased all the 2's from my mind and then looked for the next unique number, which was 3. So I wonder if we could, find the first unique number, and then we can store it in U, and that's stored in the first index of U, and then remove all occurrences of that number. So we would start with A is, what we have above, and then we're going to store U1, we're going to store 2 in U1, and then we're going to remove it. So we have this new A, which is going to be 3, 3, 3, 8, 6, 5, 6. And now that we have a new first unique number, which is 3, we're going to find, in this case, the second unique number, but it's the first in this new array. So I'm going to say first unique number in A, and we're going to store that in U2, and then we're going to remove all occurrences of the number. So U2 is going to be 3, and then we're going to end up with a new A, which is 8, 6, 5, 6. And then we're going to keep doing this. We're going to keep doing this little section again and again. This has not helped us solve for H yet. We will get there. But let's first see if we can program something to get U. So we're taking the first value of A, we're storing it in, it looks like we have, this index, where this index is going to end up being, say, a count of the unique numbers. So, if we had all 2's, then our count of the unique numbers is only going to be 1, right? There's only one unique number in there. But here we also have 3, so we have, 3, and it's going to end up being 1, 2, 3, 4, 5 values in U. So we're going to find that unique number. We're going to store it in, say, u of I. We're then going to remove all the occurrences of that number in A. And then go on to the next unique number. So let's open up MATLAB and see if we can start doing that. So here I've started my function. I'm just gonna put these uppercase. It doesn't matter really, as long as we're consistent throughout our function. The first thing I want to do here, sorry, I was gonna say something, but then I changed my mind. Something I want to note is when we see A, when we get this input A, we don't know how many unique values there are. So we don't know how many times we're going to run our loop. Because this is a loop, right? We see repeating, so we know we're going to use a loop, but we don't know how many times we're going to run the loop. So instead of using a for loop, which is what we use when we know how many times we're going to run it, let's use a while loop. And if we had continued this, we're basically going to continue this until A is empty, until there's nothing left in A, until we've removed all of the unique numbers from A. So let's come here and say while. There's several ways that we can check for if A is an empty array. We could say is empty of A is equal to 0. So that's saying is empty of A is false. We could also say while the length of A is greater than or equal to 1 is another way that we could say that. I tend to use is empty of A is equal to 0. So this means while A is not empty. So while we still have unique values in A, keep running. Let's start a little counter for how many unique values we have. We're going to start with 0 unique values. Then we are going to take the first, or change that to 1. We're going to take the first value of A and put it in the ith value, or the ith index of U. So we're going to say U of I is equal to A1. So we're put first value, first index value of A, first element. That's the word I'm looking for, first element of A in ith index of U. So for that example, that's taking 2 and putting it in the first index of U. It's taking 3 and putting it in the second index of U. And then we're going to have an I equals I plus 1 in there. So now we've found the first unique value. We've stored it in U of I. Next, we need to remove all occurrences of that number. One way we could do this is we could have a for loop that goes through every value of A and checks if it's equal to A of 1. If it is, save that index and then delete all the values with that index. That code gets a little messy. So I'm going to try to come up with another way using logical indexing. So what I want, first let's look at our logical indexing. So here I have A, which is our array. If I say A equal to 2, then I get a logical array where it's 1 where A is equal to 2 and 0 where it's not equal to 2. I can also say, So remember that's A. I could say A of A equal to 2. And that means I'm going to get all of the 2's. I could set this equal to something, so I could say A of A equal to 2 and maybe set those to 20. Now we see that all of my 2's have changed to 20. So this says find all the places where A is equal to 2 in the array of A and set them equal to 20. We can also say remove them. So A equal to 20 is empty. And now we have removed all of those values. So we're going to use something that looks just like this. So we're going to say remove all occurrences of A1. So we'll have A of A equal to A1 equal to an empty array. We haven't figured out H yet, so I'm just gonna do some random value here, not a number. And I'm going to run my function just to see how it's working so far. So this is my unique of A. So we do end up with, oh, we're missing 2. So I must have an error somewhere. Oh, because I removed 2 from A in the command window. Sorry, let me retype 2 or retype A and then retype this line. There we go. Ooh. Okay, so we have all of our unique numbers, 2, 3, 8, 6, and 5. Now we want to figure out how many occurrences of each of those we have. We can do that by looking at A, but at this point, A is empty. So let's go up here, and before we take all the values of A away from A, let's make an A copy to use in the second part of our code. So what I'm going to do, let's see. So we have A and U at this point. I am going to, there's so many ways we could do this. I think I'm going to circle through each value of U. So maybe I'm going to have a for loop for I equals 1 to the length of U. And then for each value of U, I'm then going to compare it to each value of A. So, see if they're equal, and if they are, I'm going to add 1 to my counting. So in order to do that, I'm going to need 2 for loops for, let's say, J equals 1 to the length of A. And we're going to compare U of I and A of J. If equal, then maybe we have a counter, C equals C plus 1. If they're not equal, then just go to the next J value. In order to have this C, or sorry, not C, we can put it directly in H, in the ith value of H equals H I plus 1. This requires us to, because H of I is on the right hand side of an equation, we need to define H up here. So maybe H is 0s, 1, length of U. And that should work. So we're saying for I equals 1 to U, so we're starting with this 2. And then for J equals 1 to the length of A, so we're comparing 2 to 2. They're equal, so we're going to add 1 to h. Then we're comparing 2 to 2. They're equal. We're going to compare 1 to h, or sorry, add 1 to h. So at this point, h is 2. Compare 2 to 2. H is 3. Compare 2 to 3. H is still 3. H is still 3. H is now 4. And then for all the other values, they're not equal. So h is 4, h is 4, 4, 4, 4. And then we're going to go to the next value. We're going to go to this 3. We're going to compare it to each value and add 1 to our h value if they are equal. So let's program that up. So let's say for I equals 1 to the length of u. First, we're going to make h equal to a bunch of zeros. 1 comma length of u. Semicolon. So for I equals 1 to the length of u, for j equals 1 to the length of a copy, we're going to say if u of I is equal to a of j, then h of I equals h of I plus 1. Let's try this out. Index exceeds matrix dimensions. Oh, sorry, this should be a copy because A is empty, so of course we're not going to get anything there. So 4 occurrences of 2, 3 occurrences of 3, 1 of 8, 2 of 6, and 1 of 5. Another way that we could have done this right here is to, so I'm going to comment this section out. And we still need a for loop. So for I equals 1 to the length of u, and we could use the, how do I want to do this? So we can say, I'm not sure if this is going to work. Hold on one sec. So we can create a logical where, let's say our index is a copy equal to u of I. So remember this right here, and let's put a semicolon here, is going to be an array of 1s and 0s. So here we have u equals a equal to 2, and we're going to get 1s where a is equal to 2, 0s where it's not. So this is a true-false statement. And then can we sum that? Yep, so we can sum that up and get that there are 4 occurrences. So we can come here and say h of I equals the sum of end, and that should work for us. Let's see. Yep, works just fine. So either one of these methods will work, and I'm sure there are plenty other methods. One of the times I programmed this, I ended up with everything inside my while loop. So there was a for loop inside my while loop where I removed the occurrences of A1 and counted as well within that for loop. So again, there's so many different ways to program this. If you came up with a different way, feel free to put that in the comments section below.